Now, in this example, we will tackle a substitution problem that involves the logarithm formula. So first, let's establish our u. Generally, what we will consider as our u is the function with the higher degree. For example, our numerator is y/2, and the highest degree in the expression is 1 because this is y to the power of 1. And then, in our denominator, our highest degree is 2, which is from y squared. As such, what we will treat as our u is y squared plus 4y plus 9 because this is the function with the higher degree. Again, we are interested in cancelling the variables that we will not be integrating. So let me just remove these, and then our u will become y squared plus 4y and then plus 9. And so differentiating u with respect to y, we have du is equal to 2y and then plus 4, and then we have dy. Now notice that if we will isolate dy, we have dy is equal to du divided by 2y plus 4, and so we can actually substitute this one. So this is our dy, and then we'll replace that with this, and so we have the integral of y+2 divided by our u and then multiplied by dy, which is du over 2y plus 4. So this is du over 2y plus 4. However, notice that we want to integrate u. However, we still have y+2. And then again, you will know if you're on the right track, if your expression here will cancel the expression here that you will not be integrating. Again, we are integrating u, so we need to cancel this one. Now, in order to do that, we need to do some extra steps. Notice that in 2y plus 4, both of the terms are actually divisible by 2. And so we can take out 2, and then this will become 2, and then 2y divided by 2 will give us y, and then 4 divided by 2 will give us 2. So this is plus 2. And so let's just replace this one. This will become 2 times y plus 2. And then let me just remove this one. And so here, we can cancel y plus 2 and y plus 2. And so we are left with du divided by u times 2. And so rewriting that, we have du divided by u times 2. And then recall that we can just move this outside because this is a constant term. And so that will be 1/2. And then let's just remove this one. And so now, we will just be integrating du over u, which is just ln u and then plus c. Now, just to reiterate, it is always our goal to eliminate all unwanted variables. That's why we factored this out in order to cancel this one. And so moving on, integrating du over u, we have ln u and then plus c. And then let's not forget our constant term. So this is actually times 1/2. But then we need to substitute back our original equation. And so our u here will become y squared plus 4y plus 9. And so this will be 1/2 times ln, and then we have y squared plus 4y and then plus 9. And then let's copy plus c. And so this is our answer. However, in some cases, you will need to simplify this further. Now, we have to recall that ln of u to the power of something, let's say n, that will just become n times ln times u, because you can just move this here. And so applying that here, we can actually make this as our exponent. And so our alternative answer will be ln and then y squared plus 4y plus 9 to the power of 1/2. So this is 1/2 and then plus c. And so this will become ln square root of y squared plus 4y and then plus 9. And then let's not forget our arbitrary constant. So we have plus c. And so this is our answer. Or this one. However, the reason I'm showing you the two answers is because in your exam, this may appear in the choices instead of this one. And so if you don't know how to rearrange this one, you will not know that this is just actually the same with your answer. And so be wary of this. And then if we'll do our checking, we need to input this inside ddx. So we have ddx and then ln square root of y squared plus 4y and then plus 9. And then let's just substitute, let's say 2. By the way, we are lacking a parenthesis here. And so substituting 2, we have 0.190476190.5. And so I will just store that at a so that I can recall the value later. And then let's go back to our given. We have y plus 2 divided by y squared plus 4y plus 9. And so let me just type that one. We have y plus 2 divided by x squared plus 4y and then plus 9. And then substituting 2, we will get 0.190476. And so let me just store this one, and then we'll compare our two answers. First, we have 0.190476, and then for this one, we have 0.190476. And so that means that this answer is correct. And then likewise, if you will just type this equation, you will also get this value. So ddx and then 1/2 times ln y squared plus 4y plus 9 and then 2 we have 0.190476. And so these expressions are just the same. And then just be careful in your exams if ever only one of the choices will be given.